Okay, so we're moving on to the second part of today's notes, which is, of course, division of radicals, and I'm on page 20 in the notes. Should have already written that down in your TOC, so I'm going to go straight to the paper here. So again, I'm on page 20. This is division of radicals. And we're going to start off with a step or a rule. So step 1 is going to be the same thing that we saw with multiplication, and that is simplify the radicals. And still leave inside as factors. Step 2 is just a little bit different. So simplify outside numbers with greatest common factor, otherwise known as GCF, if one exists. May not. So step 3 simplify. I put simply up here instead of simplify. Simplify inside numbers with greatest common factor if one exists. So first we're going to simplify the radicals altogether. Then we want to look at our outside numbers, almost like a fraction. And if there's a greatest common factor, we're going to simplify the top numerator and the bottom denominator using that factor. Then we're going to go to the inside and do the same thing. Now, step 4, we're going to put this in our notes, but we're actually going to wait to go more in depth in terms of how to do it for a different day. And it's going to be called rationalize the denominator and when we do that, we're going to have to look and see, like, remove new sets from the numerator. And simplify outside numbers again. But again, we're kind of going to wait on that step. And then we should have our answer after that. And we're just waiting because there's a lot, it's a lot more in depth for on how to rationalize. And the premise there is just kind of like there's all these different types of rules in math. Like your final answer in when you're dealing with exponents should not have negative exponents, kind of like the same thing with radicals. One of the rules is that your final answer should not have a radical in the denominator of a fraction. So if one exists, what we do to get rid of that is something called rationalize the denominator, which has its own steps. So these are our steps and rules. We're going to go ahead and do a few examples of them. So for the dark blue. So if we have 3 radical 8 over radical 64, right? So if I'm going to simplify, I'm going to look up top. Well, 3 radical 8, 8 has a prime factorization of 2 to the 3rd power. So there is going to be a 2 that gets to come out there, leaving a 2 behind. And 64 is actually a perfect number, a perfect square number. So 8 is going to come out, leaving me with 6 radical 2 over 8. Then to simplify the outside numbers. So 6 and 8, they have a greatest common factor of 2. And if I divide both the top and the bottom by 2, then I'm going to get 3 over 4. The inside number, well, I only have one inside number, that's radical 2, so there's going to be no simplification here. I'm not going over rationalizing the denominator today. So when I put that back together, I have a 3 up top and a radical 2. I have a 3 up top and a radical 2, and that's over 4. And that's as simplified as we can get. Now, some of you might think, well, 2 and 4 have a common factor. They do, but just like when we think of multiplication, we do inside times inside, outside times outside. With division of radicals, we can only look at outside versus outside, inside versus inside. We can't cross over. So radical 2 and 4 are kind of like not the same type of numbers. That's why they cannot be simplified. Go and do another example. So let's look at 5 radical 63 over radical 28. Well, I know 63 is made up of a 9 times 7, and the square root of 9 is 3. So I'm going to get 5 times 3, leaving behind a 7. And 28 is 4 times 7, and radical 4 would be 2, so I'm going to get a 2 radical 7. And if I multiply those together, I wind up with 15 radical 7 over 2 radical 7. So outside numbers 15 and 2, there's none. They don't have a GCF. Inside, I have radical 7 over radical 7. So my GCF is radical 7, because any number divided by itself is equal to 1, right? 2 divided by 2 is 1. X divided by X is 1. So 7 divided by 7 is 1. So on top, I have 15 radical 2, 15 over 2. And then if I multiply that by 1, anything multiplied by 1 is itself. So I'm left with just 15 over radical 2. Now, I know some of you guys are tempted to change it to a mixed number or a decimal. Don't. This is algebra. We prefer fractions to decimals. So an improper fraction is fine. When in doubt, leave it as a fraction and simplify any common factors out. So some things to keep in mind when you're dealing with fractions. The square root of, say, 16 over 25, I could write that all under one big sign, or I can break that up as radical 16 over radical 25. These have the same meanings, okay? And then I would have 4 over 5. That's what it would simplify to be. If I have the radical 21 over the radical 28, I can look at this and say, well, 21 and 28, they have a 7 in common. And I could decide to simplify the insides first before I even dealt with the outsides. If I did that, I'd be left with radical 3 over radical 4, which would give me radical 3 over 2, because the square root of 4 is 2. Right, so I can do that right away, versus if I left it inside, I'd have to remember that 21 is 3 times 7. And if I took out the 4, making it a 2 radical 7, I'd have to see that they have that factor in common and cancel that out. So either one is acceptable. But it's really super important to know that this and this are the same thing. So even if it's all under a gigantic sign, I can break those pieces apart. Because if I had something like radical 5, make a big one, radical 5 over 49, right? If I didn't break that apart, I would just leave it as that, when in fact radical 49 is equal to 7. So I'd have to leave this as radical 5 over 7. Okay, so this is where we got to put our division, our fraction skills to the test. And that is division of radicals without rationalizing the denominator, which we will get to on a different day.